In this lesson, we are going to further analyze the discontinuities in our rational functions. You will notice that this is the first function in your notes, f of x, and we have the graph to help guide us through this lesson. The first thing that we always want to do is rewrite the function in completely factored form. Before we do that, though, I want you to notice that they do tell us the exact coordinates of the hole in the graph. It's pretty easy to see that the x value is 3, but the y value is a bit vague simply by looking at the graph. So they give us these coordinates. Let's go ahead and factor. So when we factor the numerator, this trinomial factors into the two binomials, 2x plus 1 and x minus 3, and the denominator factors into x minus 3 and x plus 2. If you are still struggling with factoring trinomials, please see me. We can set up some time to go over this together. I've done so with other students and have been able to help them conquer this skill. It's very important that you're able to factor these functions before proceeding. Now we're going to identify the restricted values. This would be the vertical asymptote at -2 and the hole, which is 3. You could also take a look at setting your denominators equal to 0, the two factors in the denominator equal to 0 and solving. If you set x minus 3 equal to 0, you get 3, and if you set x plus 2 equal to 0, you get 2. So our two restricted values are -2 and +3. Now we're going to rewrite the function in simplified form. This just means we're going to cancel out any factors that are common to the numerator and denominator. And you will notice that both the numerator and denominator have a factor of x minus 3, so we're going to cancel that out. This leaves us with the simplified function f of x equals 2x plus 1 over x plus 2. Now we're going to identify and classify the discontinuities from the graph on the function, which I mentioned earlier. We notice that x equals -2 has a vertical asymptote, and x equals 3 is a hole, also known as point discontinuity. What factor cancels out of the function, and what type of discontinuity occurs at its restricted value? Remember that x minus 3 was the factor that we canceled out of the numerator and the denominator. And we know if we set this equal to 0, we're going to get a hole. We're going to get x equals 3, where there is a hole in the graph. What factor does not cancel out, and what type of discontinuity occurs at its restricted value? Well, x plus 2, actually that should say x plus 2 did not cancel. And when we set that equal to 0, we get x equals -2 is a vertical asymptote. So the factor that does not cancel gives us our vertical asymptote. This is the factor in the denominator. There are 3 other graphs in your notes for you to practice. I have not included them in this video, so please pause and complete those other 3 before proceeding. If you would like, you can check your answers with the notes that I have uploaded there in your Schoology folder to make sure that you filled out the chart correctly. Based on the information that you have gathered in the table, what inferences can you make connecting the equation of the rational function to the location of the discontinuities on the graph? Pause and think about this for a moment. One of the things that we've already discussed is, of course, that the discontinuities occur at the restricted values. That's what we get when we set the denominator factors equal to 0 and solve. If a factor cancels out, then its restricted value is a hole, or point discontinuity. If a factor does not cancel out, then its restricted value is a vertical asymptote, also known as infinite discontinuity. Let's take a look at this function one more time in simplified form. Again, we cancel out the common factors, and that leaves us with this function 2x plus 1 over x plus 2. Now, looking at this simplified version, at what x value does the graph of f of x have a point discontinuity or a hole? You might remember that we found the hole to be at x equals 3. So now we want to find the value of f of x at x equals 3. Of course, this simply means that we're going to substitute 3 into the function, and we get the corresponding y value of 7/5. What were the coordinates of the whole of f of x from the very first page of our notes? Y 3, 7/5. In your notes, complete the table for the other 3 graphs before proceeding. So basically what you'll be doing is finding the corresponding y value that goes with each x value for the whole by plugging in that value into each function. Based on the information in the table, what inference can you make about how to find the coordinates of the hole in the graph, the point discontinuity of a rational function? Pause and think about this for a moment. The x value is found by setting the canceling factor equal to 0 and solving for x. The y value is found by by substituting the x value into the simplified function and computing. The end.